You know, when a nation needs to essentially upgrade its entire economy, we usually picture pouring concrete and laying asphalt.
Right. Massive physical projects.
Exactly. We imagine like highways being carved out of dirt, massive physical power grids being strung up across mountains, or giant bridges taking years to connect isolated cities. It's a really slow, grueling process that can take decades to complete.
Oh, easily decades, yeah.
But today we are looking at what happens when an entire country decides to just skip the concrete altogether.
Just bypass it.
Yeah. What happens when a region decides to leapfrog those traditional physical steps and jump straight into the digital age in a matter of months? Welcome to the Deep Dive.
Thanks for having me.
Today we have a really fascinating mission for you, the listener. We're going to explore how massive macroeconomic gaps in emerging markets are being filled by rapid, large-scale technological leapfrogging. And to help us understand exactly how this digital plumbing is being laid down across entire nations, I'm joined by the CEO of ATMC.
It's really great to be here.
They are a global IT solutions company at the very forefront of this transition. And our focus today is strictly on your company's ITES apps, which stands for Information Technology Enabled Services. We'll be looking at the three-tier architecture powering those apps and a product catalog so massive it almost defies the conventional rules of the tech industry.
Yeah, it's quite the catalog, but if we look at the bigger picture right from the start, my company's executive vision has always been focused on just a single mechanism.
Okay, and what is that?
Our goal is to bridge complex consumer requirements with certified professional providers worldwide. That's it. And my team accomplishes this by building comprehensive, state-of-the-art digital ecosystems.
Right.
We look at service economies that have historically relied on really intense manual processes, so like clipboards, physical filing cabinets, landline dispatchers.
Very analog stuff.
Very analog. And we provide the underlying digital infrastructure to completely automate them.
Well, let's unpack the scale of that infrastructure right away, because for anyone listening who follows the tech sector, your approach is incredibly counterintuitive.
I've heard that, yeah.
I mean, the conventional wisdom in software is to find one tiny niche and just obsess over it. A company builds a ride-hailing app or, they build a food delivery app, and that's their entire business model.
Right, the single-purpose model.
Exactly. But looking through your company's portfolio, you have over 25 distinct ITES app categories. Instead of building one app, it looks like your team has essentially built a digital business in a box for almost every conceivable industry.
Basically, yeah.
How do you manage that kind of horizontal spread without, spreading your engineering team completely thin?
You would think it creates chaos,
Mhm.
honestly. But the reality on the ground taught us something very different early on.
Oh, really?
Yeah. The core problems that service industries face in emerging markets are actually highly universal, even if the services themselves look vastly different on the surface.
Right, okay.
So our team has developed solutions across heavily diverse sectors. On one end of the spectrum, we operate hyperlocal food delivery and advanced ride-hailing networks. This includes specific frameworks designed for regional transport models, like the Boda Boda and Okada motorcycle networks in Africa.
Which I imagine operate very differently than a standard taxi service in London or New York.
Oh, fundamentally differently. I mean, the routing, the pricing, the vehicle types, it all requires a highly specialized logic.
Right.
But then on the other end of the spectrum, we build highly specialized enterprise services. We have on-demand mechanic apps, integrated with comprehensive vehicle fault code glossaries.
Wait, what does that mean exactly?
It means the mechanic already knows exactly what is wrong with the engine before they even arrive at the breakdown location.
Oh, wow. That's incredibly efficient.
It really is.
Yeah.
And we have home nursing applications that allow medical professionals to actively track a patient's vital signs and medication adherence post-surgery. We even deploy platforms for legal e-notary services and verified real estate leasing that integrate directly with digital hardware lockboxes.
So you're essentially replacing the manual friction of all these different physical workflows with software.
Exactly.
But practically speaking, I mean, building a backend for a ride-hailing app and building a system for electronic health records, those are two completely different beasts.
They definitely are.
If you're listening to this and you've ever had your single-purpose food delivery app freeze just trying to load a menu, you're probably wondering how on earth one company maintains 25 enterprise-grade apps. Doesn't cramming so many different industries into one company create massive operational bottlenecks?
That is a very fair question.
Like, how do you guarantee reliability for millions of users across the 50-plus nations you serve?
Well, that is the exact engineering hurdle we had to solve before writing a single line of code. Because if we built 25 different applications completely from scratch, it would be an absolute maintenance nightmare.
It would just be impossible to manage.
It would buckle under its own weight, yeah. The answer lies in what we call our core three-tier product trinity.
Core three-tier product trinity. Okay.
Right. This is the architectural blueprint of our success, and it powers every single application variant in our portfolio. Instead of 25 different systems, my team builds 3 distinct synchronized layers for every ecosystem, and we just change the context of what those layers process.
Okay, I think we need to break down those 3 layers. How do they actually separate the workload?
Sure. So the first tier is the customer apps. These are engineered natively for Android and iOS devices. They feature ultra-responsive interfaces, premium map vectors, and highly secure lightning-fast checkouts. This tier is strictly focused on the consumer experience. It's lightweight because it doesn't need to do any heavy computational lifting. It just needs to look great and process a request seamlessly.
So that's essentially the storefront. The user opens the app, asks for a plumber or a ride, and the app just passes that request along.
Exactly, just passing the baton.
Hmm.
The second tier is where the complexity really begins.
Okay.
That's the professional apps tier. These are custom-built strictly for the service providers on the ground, so the drivers, the doctors, the plumbers, the mechanics.
For people actually doing the work.
Right. This layer features automated dispatching algorithms, turn-by-turn regional GPS routing, visual income dashboards, and offline QR hardware scanning, which is vital for workflows like event ticketing or school bus monitoring. This tier basically acts as the provider's entire mobile office.
I see. And the third tier tying it all together.
The third tier is the Web Admin Hub. Think of this as the high-performance central command dashboard. It's strictly for the system operators, local governments, or business owners. It gives them absolute operational authority.
Like a bird's eye view.
Exactly. Through this hub, they manage the overarching financial transactions, view deep analytical reports across the entire fleet or workforce, and they control dynamic matching engines.
What does that look like in practice?
Well, if there's extreme weather or a sudden supply shortage, the Admin Hub allows them to instantly implement dynamic surge pricing configurations across the entire network.
Okay, I see how separating the workload keeps the system from crashing. But let's look at the reality of deploying this. Designing a beautiful 3-tier system in a pristine tech hub with gigabit fiber internet is one thing.
Yeah, the real world is a bit different.
Exactly. You're deploying these in emerging markets. If you're operating a fleet of delivery trucks or a network of rural healthcare workers, cellular network reliability can be incredibly spotty.
Very spotty.
Doesn't the whole synchronized Trinity system break down the second a local cell tower loses power and the professional app can't talk to the admin hub?
It is a massive hurdle, and it's precisely what trips up a lot of legacy software companies trying to enter these regions. To solve this, my team engineered what we call our high-fidelity feature matrix.
High-fidelity feature matrix.
Right. The entire back-end architecture is optimized specifically to serve emerging economies, meaning the data packets we send are incredibly compressed. That ensures fast load times, even on edge networks or, low bandwidth cellular infrastructure.
Okay.
But the critical piece is the offline storage databases we build directly into the apps.
How does that work mechanically? Like, if the network goes down, how does the app know what to do without talking to the server?
So, when a professional starts a job, the app downloads and caches the necessary workflow data locally onto the physical storage of their phone. If they hit a total cellular blackout, the app doesn't freeze or kick them out.
Oh, it just keeps running?
Yeah, they can continue to check off tasks, scan QR codes, or input patient vitals. The app just logs all those actions locally with precise timestamps. And then the moment the phone detects that it's re-entered a cellular coverage zone, the app runs a background protocol that seamlessly syncs everything back up to the Web Admin Hub.
Okay, but what about data conflicts? Because if I'm a driver and I accept a cash payment from a passenger while I have 0 cellular service, the central admin hub doesn't know I'm occupied.
Right.
What stops the admin hub from trying to dispatch me to another job at the exact same time?
That was a major problem we had to solve. The system handles this through a decentralized state machine. The moment the provider's phone loses connection, the central server flags that unit's status as temporarily opaque.
Temporarily opaque.
Yeah, but it presumes they are continuing their last known task. The central dispatch will not assign a new critical task to an opaque node until a handshake is reestablished.
That makes sense.
Once the connection returns, the system resolves the timeline using the local cryptographic timestamps from the device, ensuring the central database perfectly reflects the reality of what happened offline.
Wow. So looking at this architecture, it's like you didn't just build 25 different houses from scratch.
No, definitely not.
Your team engineered an indestructible concrete foundation and a universal framing system, and you simply adapt the interior layout, like the paint, the furniture, the specific rooms, depending on whether the industry needs a hospital layout or a taxi garage layout.
That is the perfect way to visualize it. The universal technology stack our company deploys is the absolute key to our scalability. Because all these apps share that same optimized foundation, we can guarantee a 99.99% operational uptime.
That's incredibly high.
It is. Our backend core architecture relies on highly scalable microservices developed in Go and Node.js. And for the real-time data layer, which is critical for tracking a moving taxi or a delivery courier, we use high-speed WebSocket networks running alongside fast Redis caching databases.
Wait, pause for a second. For the listeners who aren't software engineers, explain things like Go, Node.js, and Redis's in plain English. What are those actually doing for the user?
Okay, yeah. Think of the whole system like a massive restaurant kitchen.
Ah,
Node.js and Go are the specialized head chefs.
okay, tracking.
Node.js is incredibly good at handling thousands of tiny simultaneous requests, like taking orders from 1,000 different tables at once without getting overwhelmed.
Right.
Go is the chef you hand the intensely complex, heavy-duty math to, like calculating the optimal routing for 500 delivery drivers in real time.
And what about the WebSockets and Redis?
Normally, an app has to constantly ask the server, has anything changed? Has anything changed? Which takes time. WebSockets are like a permanently open radio channel between the phone and the server, so the server can just instantly push an update down to the phone the millisecond it happens.
Oh, I see.
And Redis is essentially the kitchen's prep station. Instead of walking all the way to the deep freezer, which is the main database every single time you need an ingredient, Redis keeps the most frequently used data right on the counter in the computer's active memory.
That's a great analogy.
Thanks. That combination is what gives us instant sub-second location updates on the map.
Okay, that makes perfect sense. But let's talk about those map updates. Because if you are tracking thousands of moving motorcycles or trucks across a sprawling city, the processing power required just to draw and update those maps must be astronomical.
It's a lot of data.
And processing all that mapping data on a local phone must drain the battery incredibly fast, especially in areas where a driver might not have easy access to a phone charger all day. How did you work around the battery drain?
Yeah, if we relied on basic third-party mapping APIs that constantly pinged external servers, the overhead costs would be massive. And yes, the battery drain would make the app unusable. So my team built a custom ultra-low latency geofencing and mapping engine. We optimize what are called dynamic polygon lookups directly on the device edge.
Dynamic polygon lookups on the device edge, that sounds like a geometry nightmare.
It's a bit complex, yeah.
Are you basically saying the phone itself is drawing the map boundaries so it doesn't have to constantly ask a server miles away where the car is?
Precisely. Instead of the phone sending a GPS coordinate to the central server every single second and asking, am I inside the surge pricing zone yet? We send the invisible boundary lines, the polygon, down to the phone once.
Oh, wow.
Yeah. The phone's own processor checks its location against those lines locally. By processing those complex spatial boundaries on the user's actual device, the edge of the network, we bypass the need to transmit data back and forth.
That's incredibly smart.
It saves massive server overhead, drastically reduces battery consumption because the cellular antenna isn't constantly transmitting, and, increases responsiveness dramatically.
I want to look at the human element of this architecture now. The mapping is highly efficient, but when you are dealing with service providers in emerging economies, freelancers, independent contractors, the most critical element is trust.
Absolutely. Trust is everything.
Right. If I am a freelance plumber in a market without strict legal recourse, I am not going to drive across town and buy parts unless I know the money is secured. I imagine trust is the biggest bottleneck in getting these service economies off the ground. How does your universal architecture handle the money? Are you acting as a digital middleman holding those funds?
You have correctly identified the biggest barrier to entry. Trust is the actual currency of an ITES ecosystem. We realized early on that just connecting two people wasn't enough. We had to guarantee the transaction.
Right.
That is why we integrated a multi-currency and cross-border payment matrix directly into the core engine. But the truly transformative mechanism is our built-in micro-escrow disbursement framework.
Walk me through the state machine of that escrow. Like, how does it operate mechanically during a job?
So when a customer requests a service, say booking a home cleaner or hiring a freelance designer, our system immediately captures those local or cross-border funds and moves them into a secure digital escrow vault.
Okay, so the money is locked up.
At that exact moment, the service provider's app updates to show that the funds are verified and locked. They know the customer has the money, and the customer knows the provider can't just take the money and run.
Because the funds are restricted.
Exactly. They are absolutely restricted. They are not released to the provider's wallet until the job is physically completed and the customer submits the final verification sign-offs inside their app. The platform acts as the impartial, automated guarantor for every single transaction, removing the anxiety of non-payment.
Okay, so you have solved the offline tracking, the map processing, and the payment trust. But I really want to explore the macro impact now, because an app that hails a motorcycle is one thing, but you also mentioned hospitals earlier.
Yes, healthcare is a major sector for us.
The stakes of an app crashing while ordering food versus tracking surgical supplies are completely different. Healthcare requires massive data compliance and privacy firewalls. Doesn't putting a taxi app and an electronic health record system on the same foundational architecture create massive security vulnerabilities?
It would if they share the same database, but they don't. No, the shared foundation is the structural methodology, the way the code runs and communicates. We use strict containerization and microservice isolation. The healthcare ecosystem operates in a completely sealed, compliant digital vault that just uses the same efficient logic pathways as our logistics tools. And the impact on those complex supply chains like healthcare is where you see the true macroeconomic shift. Take our ATMC hospital ERP platform. It is not just an electronic health record for doctors to look up patient files. A hospital is fundamentally a massive life-or-death supply chain.
Right, managing resources.
Exactly. The ERP tracks the real-time inventory consumption of critical goods, things like IV fluids, surgical supplies, or anti-malarial medications.
So the central admin hub always knows exactly what is sitting in the supply closet.
It goes far beyond just counting stock. The system incorporates predictive AI models. It constantly analyzes current patient admission rates, seasonal illness trends, and historical consumption data.
Okay, so what does it do with that data?
The AI will actually predict a shortage of a specific medication days before the shelf is empty. The ERP can automatically generate and transmit a purchase order to the regional medical distributor before the hospital runs out of antimalarials. We are fundamentally moving entire national health systems from a reactive crisis management model to a predictive automated model.
Wow, anticipating the medical need before it becomes an emergency. You also mentioned education scaling in a similar way.
Yes, through our EdTech and human capital modules, we build highly scalable multimedia e-learning and masterclass apps.
For schools.
For schools, but also for enterprises. If a massive enterprise workforce or a regional government needs to upskill thousands of civil servants, they can't afford to send them all to a physical classroom.
No, that would be incredibly expensive.
Right. Our platform allows them to deploy customized asynchronous training. The employees download the modules, learn offline at their own pace, and take secure assessments. The central admin hub tracks all this progress dynamically. It allows human capital to upskill and adapt at the exact same velocity that artificial intelligence is changing their industries.
Here is the realization that I think is truly staggering for anyone listening to this. You have built an ecosystem covering hospital supply chains, digital banking, e-government training, and logistics. Because ATMC built all 500 plus of these discrete software solutions on the exact same underlying digital architecture using the exact same data logic, the friction of integration in the future essentially drops to zero.
Yep, that's the magic of it.
If a national government deploys your health tech platform this year and then decides to deploy your e-government identity system next year, they don't have to hire an army of consultants to figure out how to make the two databases talk to each other. They already speak the exact same digital language.
That is the ultimate goal. We are providing a deeply interconnected digital fabric where data can flow securely and instantly between different sectors of an economy.
That is wild.
But having powerful interconnected technology is really only one part of the equation.
Which brings us to the actual deployment. Because the technology clearly works, but the physical rollout is often the hardest hurdle. How does a single tech company navigate the cultural, political, and logistical friction of launching software in over 50 incredibly diverse nations? I mean, trying to dictate the cultural nuances of a hyper-local transit market in East Africa or a specialized property rental market in the Middle East from a central office thousands of miles away seems logistically impossible.
It is completely impossible, and it was a hard lesson the broader tech industry had to learn. You cannot parachute into a foreign market and pretend you understand their daily operational friction.
Right.
So my company simply doesn't do that. We utilize a highly structured, decentralized partnership model. We empower local entrepreneurs to take absolute ownership of their specific markets.
How does that partnership actually function? Are they just buying a white label software license from you and reselling it?
It's a much deeper integration than that. We offer structured tiers of partnership: master franchisees, agents, and referral partners. These local partners can earn up to 35% commission on the ecosystem's revenue.
That's a huge incentive.
It is. They act as the trusted cultural face of the entire operation. The local entrepreneur or agency handles all of the heavy lifting on the ground: the customer acquisition, the physical sales meetings, the localized marketing campaigns, and the daily relationship management.
Because they know the market.
Exactly. They understand the local regulatory environment, the local banking quirks, and the consumer habits better than my engineering team ever could.
So they provide the local trust, the regulatory navigation, and the operational hustle, and your team just hands them the keys to a world-class technological engine.
Exactly. We provide the enterprise-grade technology from our catalog. This synergy solves the deployment bottleneck entirely.
How fast can you actually deploy then?
Well, it means a local municipal government or a private entrepreneurial group can identify a massive gap in their market, say, the need for a unified city transport and digital ticketing system. They partner with us, and we handle the architecture, the user interface design, the security audits, and the App Store deployment. We run 2-week agile development sprints, and we can take them from the initial contract discovery phase to a fully live, customized deployment in as little as 90 days.
Wait 90 days.
90 days. The local partner launches a premium tech business with zero internal technical overhead, and we achieve deep, effective market penetration that is culturally authentic.
90 days to go live with a citywide digital transport infrastructure. That is the literal definition of leapfrogging.
We think so.
To summarize the core mechanics of what we have unpacked today, for you listening, we are looking at a system that takes a highly stable, deeply optimized 3-tier architecture, adapts it into over 25 different service categories, and systematically digitizes entire supply chains across the globe.
That perfectly sums it up.
By engineering clever solutions to offline connectivity conflicts, automating trust through digital micro-escrows, and handing the operational reins to local entrepreneurs, this framework is quietly rewiring the economies of emerging markets.
My team and I take immense pride in the ecosystems we're deploying. For us, the mission has always been about acting as a foundational catalyst. By equipping global businesses and local entrepreneurs with accessible premium digital tools, we are watching IT-enabled service economies flourish in ways that simply weren't technically viable even 5 years ago. It is a genuine privilege to build the architecture underlying that kind of global transformation.
It is a fascinating look at how scale and strategy intersect. And before we wrap up today, I want to leave you, the listener, with a final thought to mull over. We have seen how incredibly efficient it is when one system handles the health tech, the e-government identity, the logistics, and the banking. But when a single overarching architecture provides the foundational digital plumbing for an entire region, what does the future of national infrastructure actually look like? When the friction of data integration across all these different sectors drops to absolute zero, does a nation's entire economy simply become one massive interconnected app? Something to think about until our next deep dive.